All right, crew, it is time to move on to dilations. So we have now done translations, reflections, rotations, and all of those were what we call congruence transformations because the original shape and its image are exactly congruent. Dilations, however, are not a congruence transformation because it actually changes the size of the shape. So a dilation is a transformation in which a figure is either enlarged, made bigger, or reduced, made smaller. And to find a scale factor, which is telling us how much bigger or how much smaller something is, that is just the ratio of the image to the pre-image. So remember, image is the after, that's the one with the primes. And the pre-image is the before, the original. So if we are given two shapes and we're trying to find the scale factor, we take a measurement or some information from the image, the after, and we divide that by the pre-image and we just simplify it. Let's look at an example of that. So we're trying to figure out what the scale factor of the dilation is in both of these pictures. I'm going to do A with you, and then I want you to pause the video and do B and check yourself. So it's important to note which one is the image, which one's the prime, and which one's the original. So when we're trying to find the scale factor, we do the prime or the image measurement over the original. So in this case, the 12 gives me the measurement from that C, which is the center of dilation, out to the prime. So 12 would go in the numerator. And then P would be the original one, would be 8. So now I just need to reduce that. So I'm going to divide these both by 4. And I get that the scale factor is 3/2. Now, if the scale factor is greater than 1, it's an enlargement. If the scale factor is less than 1, it's a reduction. So in this case, it would be an enlargement, which we could also tell that just by looking at the original, or at the picture, because the original one is here, is definitely smaller than this one. So we're enlarging it as we go from the original to the image. Okay, now I want you to pause the video and find the scale factor of the second one and tell me whether it's a reduction or an enlargement. So on this one, I need to put the 18 on the top because that goes to the image and the 30 goes with the pre-image. So I'm going to divide these both by 6 and I'm going to end up with 3/5. So this is less than 1. So this is a reduction, which you can also tell because the paper clips are getting smaller as you go from the pre-image to the image. Now, what do dilations look like on the coordinate plane? How do you find them? So the shortcut, or kind of the way that we do dilations, is that xy goes to kx comma ky. K stands for your scale factor. And all you're really doing is multiplying your x and y values by that scale factor. So if your scale factor is 2, you multiply the x and y values of everything by 2. If your scale factor is 1/3, you multiply everything by 1/3. And that ends up dilating or reducing your original pre-image to be your image. So let's look at an example. So we need to graph this triangle and its image after a dilation with a scale factor of 2. Now I'm actually going to find the coordinates of the image before I graph them. That's just my preference. You do whichever way makes more sense to you. So I'm going to start by doubling all of these because that's what a scale factor of 2 does. I'm just going to multiply all of these by 2. So now I'm just going to graph my pre-image and my image. So I'm going to zoom in a little bit. Okay, so first I have A is 2, 1. B is 1, 1. C is 3, -1. So here is my original triangle. I'm going to do my image in red. So now I'm going to graph 4, 2. make sure you're labeling your points, 2, 2, and 6, negative 2. So see how the shape itself doesn't change, but it is twice as big. So like this original AB is 1 unit long, A prime B prime is 2 units long, and so forth. So that's what that dilation is going to look like. So I want you to do this one on your own and then check and see if you got it right. But first, think about, is this going to be a reduction or a dilation or an enlargement? And this is going to be a reduction because 1/3 is less than 1. But you might be thinking, what about that negative? What does the negative do? So go ahead and find your new coordinates and graph them and see if you can figure out what that negative did. So let's find K prime, L prime, M prime, and N prime. So we're going to multiply all of these by negative 1/3. So this is going to become a positive 1, negative 2. This will be 0, negative 2. This will be negative 1, negative 1. And this one will be positive 1, positive 1. So if I graph the original, it's a negative 3, 6. 0, 6, 3, 3, and negative 3, negative 3. So here is my original. So now in red, I'm going to do the reduction. So 1, negative 2. 0, negative 2. Oops, I need to label like I tell you guys. Negative 1, negative 1, and 1, 1. So when I graph this, not only is this a reduction, it's 1/3 of the size. This didn't graph very well, but it also has flipped where it is. It's on like the other side. Instead of being on the top, it's on the bottom. So when your scale factor is negative, it not only enlarges or reduces, it also kind of flips it over to the other side of the graph. All right, that is all I have for dilations. Here's a blank page to write yourself notes or give yourself an encouraging message like you got this.